and particularly we'll look into the AI understanding of what the stakeholders are trying to orchestrate in terms of the understanding. It's a, I think, 60 plus page documentation, and we'll go through and try and compare it with China and Europe. Already, if we understand the way we understand, um, China is already married to AI in terms of the regulations, in terms of the implementation, in terms of the bifurcation of the Internet of Things, in terms of the deployment of handheld devices, apparatus, and the others in a fast, speedy fashion. However, the opinion of what the stakeholders are talking about, we'll just get into it and delve with that, and also would be looking at the coding part of the smart contract on the Impula network. So I'm putting myself on mute, and then we'll start in a while. Okay, we'll start with the understanding of the coding part first of all, in terms of the tags to be utilized for understanding the landscape over the years, and particularly we can look into the landscape from the standpoint view of the European Union, because a lot of stuff has been developed in the historical data set. So you have to go into the historical data set, retrieve the data, and then see how that can be utilized for the Impula network for the 6G connectivity. And particularly when we are deploying the Impula network, that is futuristic in nature, because the core of the Impula is based on the fact of taking into consideration the historical data sets and the environmental data sets. So environmental data set is kind of the present data sets in terms of the input data set at any given point of time. Even devices like this are good enough to have some kind of data in terms of the input data, and that can be utilized to calculate. And with the historical data set, you can be futuristic and deploy it from the emergency point of view. So wherever there is emergency in terms of a natural calamity, that can be easily be obviated, not mitigated perhaps, but obviated in a manner when the data set is good enough, and when the data set is developed in a controlled environment, that is going to take care of the futuristic stuff. Okay, so first of all, we'll talk about angiography, that is G01R33/53, 5635. So it's G01R33/5635, which is CEMRA, that stands for contrast enhanced angiography. And the other one is time of flight angiography, that is TOF-MRA. Now, when we are taking into consideration, particularly, the power of the G tagging is all about physics. However, how you're utilizing the physical understanding of the physics in terms of the magnetism, it is something very well understood when you are putting into consideration the magnetic understanding of the magnets. So you need to understand the measurement of magnetic variables involving magnetic resonance using the NMR, that is nuclear magnetic resonance. So when we're talking about the NMR imaging system, particularly from the satellite point of view, it worked wonders, because in this space I would be talking about and taking you through the landscape of few of the applications where, let's see what all I can cover today. So I really want to keep the understanding in a very close format so that it's easy for the folks to understand and deploy it on the Impula network for their own satellite communication, and taking into account the understanding of the spectrum of we have both sides of the spectrum. So one side of the spectrum is the historical data set, at the other end of the spectrum is the environmental data set, and the marriage is here is about the nature, because nature is the biggest blockchain. Okay, so the next is when we talk about the signal processing system, that is G01R33/54, that includes your pulse sequences, generation or control of pulse sequences on an operator console. So the understanding here would be the understanding of the console itself in terms of what all can be done in the pulsating effect. So this is done, we covered this. Okay, so there is another term which is perfusing imaging, that is particularly G01R33/56366. And to resolve the MR signals of different chemical species, say for example water fat imaging. So fat molecules has missiles. I'm not getting into the understanding of fatty acids here, but here we are just scratching the surface. To have MR characterized by data acquisition, so data is very important, and real data is very important, along the K-space trajectory or the temporal order of the K-space coverage, that includes your centric and segmented coverage of the letter K space using a non-Gaussian trajectory. So there's another term which is important here is SSFP, which stands for steady state free precision to obtain the MR imaging apparatus of the magnetic resonance image, that is MRI, and the photographic conditioning to establish method in the MR imaging apparatus. So we have loads of modules here. We will go through that. I just wanted to have a little bit understanding on the slice selection. Okay, let's do this. So I'm giving a numerical number for this and the like. So you can just go to the X and look into the data set which I shared and put it into the protocol and see if that works for you guys. This is done. What's next? Okay, so when a satellite is deployed, what is the functionality of this particular machine, or I would rather say, honestly speaking, we cannot even call it a machine or an apparatus. It's a mixture of the stuff, because in space, the environmental factors is altogether different. Okay, so in this particular case, the MRI machine is supposed to click. It's a kind of a very fast camera, and it has to click quick flash photographs of the stuff. Now the stuff could be, I don't want to give a nomenclature here, but let's take it as a carriage. So it's a clever way to include the control pulses between the normal big flashes and then use the picture taken right before and right after these mini flashes to have a clearer final image. Now, how does it work? So there is fat suppression here. Here you put a bright and a dark marker on certain slices. I'm not getting into technicalities. If required, we'll go through it maybe in weeks to come. We are saturating the signal for the extra contrast, and then we keep the same slice, or we can move on to a different slice, but to have the entropy in a controlled fashion, which is next to impossible. But with the quantum understanding of the protocols which we discussed earlier, this is very much possible. So the possibilities is numerous. What is the need of the R is to scan the extract from before and the after, and if something has changed, that has to be taken into account, and according to that house of the understanding, that operator signal is signaled out in real time. So we can talk about the cancellation effect, but I don't want to get into it today. So now let's take another application. So I will walk you through a little bit about the quantum stuff. So let's talk about one of my favorite topics, that is LED, because in all these, whether it's a satellite instrument or whatever proof of work we are developing, it's very important to take into consideration the LED aspect in terms of what kind of light emitting diode would be deployed for the lighting purpose. And particularly we have talked about heat dissipation and the others which were developed way back somewhere from 2010 to 2013-14, and that is like, obviously it's almost 10 years down the lane, more than that now. That can be utilized, licensed, and seen as a way to be utilized, because heat dissipation itself has a lot of impact on the environmental factor. So we need to look into the heat dissipation part, and not as a prior art or something, but understand it from the viewpoint of what can be done in terms of gathering a high performance fabrication of the light emitting diodes in real time. Whether it can happen in India, that's a debatable question, but yes, it can happen in China, because China has all the resources to get things done in a fast, speedy manner. So there would be loads of licenses between the understanding of the countries. And I talked about it earlier also, and I'll re-emphasize here why China is way, way, way ahead of the others, particularly from the standpoint view, they have the concept of the 10 years patty patent. So patty patent is for 10 years without even, talking about whether, what are the provisions under which it can be registered. Almost every application filed under the 10 years process is granted. However, why India is not taking stand, that is the stakeholders need to answer. So neither the earlier government took any steps in that regard, neither the current government is doing anything in that regard, and that's a question mark as to the capability of the country as such in terms of what is being patented at the first place. Because the understanding of the numerical number 10, that is not there in the country, perhaps even from the blockchain point of view, and because that understanding is negligible, or rather it's just a periphery which is free for anyone to use, that doesn't create that mechanism for the technology or the innovation to foster the way it can foster. Because even with this AI Act, which is being, or whatever the AI discussion which is happening in India, it is at the periphery. And countries like China and the others, they have made it very clear as to what is allowed, what is not allowed. Because when there is no clear guideline or scrutiny at the step number 1, there would be some kind of damage which will be part of the SWOT analysis, and that is what is happening in terms of the kind of applications which are being filed before the Indian Patent Office. So at the back end, even if it is just a provisional patent application, it itself shows that the understanding of the peers or the folks in India or the citizens of the country, their understanding is not up to the mark. They still think, what is utility, what is 10 years, what is 20 years, what is licensing, what is cross licensing, what is in licensing, what is out licensing. These terms are not known to the academia people also. So if you just ask these questions to the academia people in India, I'm talking about the best of the colleges, if they think they are the best, their understanding is negligible as to what has been developed at a global basis. So that's need to be looked upon right now, stating the fact that the outsourcing model has stopped, and all those folks who have understood little bit of what the protocols all are around intellectual property, they should be going back to the colleges, teaching, or take up that expert kind of a job, just be there in multiple colleges and explain to everyone in terms of human capacity building that this is the need of the hour, and that is the need of the hour in 2025 and beyond. I'm not getting into what technology landscape has been. Few of the countries, and they have just overcome everything, and scratching surface is not going to resolve any issues at hand. Okay, so let's talk about this high performance stuff. So I already talked about the LED part, and I'll just get you through the understanding of the classification here, which is H1, okay, H10, H20/81, that is bodies. Then we have crystal structure orientation, that is polycrystalline, amorphous or porous, that is H10, H20/817. Then we have reflected materials, that is H10, H20/835, containers, H10, H20/8506, interconnections, H10, H20/857, interconnections that has bond wires, solder balls. Then the contouring part. Contouring is very important from the standpoint view of light, because even a slight deviation in light, it can create miracles, or it can just spoil the whole apparatus or the functioning of the apparatus at the first place. That is H0. Okay, that is 001L22224/14, which talks about the contouring, the material, the disposition of the bump connectors prior to the connecting process of multiple bump connectors. This takes me back to the timeline of perhaps 2011 right now. Okay, anyhow, cooling arrangements. I worked a lot on these kind of applications way back, so that's almost 15 years back. That is F21V29/70, cooling arrangements characterized by passive heat dissipating elements, example heat sink. So I worked a lot on these, and that is nothing but the deployment of capacitors and resistance at a particular angle, and that is the magic of what LED is all about. Okay, should I get into the aspect ratio or the geometric relationship? Let's see. I think for the time being, we don't need to get into this. Perhaps most of the applications are written by me. You can just go through in the online world, because I have a typical way of writing the pattern application. So that's very, very evident as to how I have written those way back in terms of chip LEDs, then flip chip LEDs and whatnot. And generally the reflective material, although the pricing is increasing, so the reflective material in most of the cases was silver, or at least one layer of dielectric. What could be the layer of dielectric? We'll just go through that. Just give me a moment. Next, I'll go to the debris part to finish this understanding. Dielectric stack, quantum dots. Okay, just for the purpose to be understood in a manner in which it has to be understood. So nanoparticles, quantum dots, semiconductor particles and other types of materials can be used as a wavelength converting material. So the good thing is, with whatever garbage we have in terms of these metals particularly, which is being I mean, I see a very big business here in terms of just collecting the garbage in terms of whatever metals we have and utilizing it for the circular economy and using it as wavelength converting material. So there is a lot of scope in that aspect. That is one business which is going to work. The other one is definitely, being carbon neutral and getting into the carbon negative understanding of what carbon negative is all about. So this is done. I further just want to semiconductor, okay, multi-quantum. Okay, I'll discuss this quantum part from the standpoint view of tagging. So nanotech now is gaining momentum, although the word nanotech has been there for almost 2 decades plus. When you talk about nanotech, the classification would be B82Y15/00. Nanotech for interacting, sensing and actuating, example quantum dots as markers in protein assays or molecular motors. Then we have electroluminescent, chemiluminescent material containing inorganic luminescent materials, that is C0 9K11/08. Bodies having quantum effect structures, example tunnel junctions within the light emitting regions, that is having quantum confinement structures, that is H10H20/812. Okay, for the LED, direct backlight with LEDs, that is G02F1/133603. Then we have wavelength conversion means H10H20/851 wavelength conversion means. Then the light sources with substantial 2D radiating surfaces characterized by chemical or physical composition or the arrangement of electroluminescent material, or by simultaneous addition of the electroluminescent material in or onto the light source, that is H05B33/14. Okay, this is good. Then what else? Let's see some bandwidth understanding. Okay, how about we get into circumpolar latitude? So we'll just discuss this, and then this discussion is good enough for the coding part on the smart contracts, which is not on Ethereum. Let me be very clear. So circumpolar latitudes, which is interesting. So first of all, let's deep dive into the understanding of what is circumpolar latitudes. Okay, it's a good lexicographic term. Circumpolar latitude is not a formal terminology, but it is used when it is referring to the belt of Earth that lies poleward of the two polar circles, that is the latitude band, inside which phenomena is described as circumpolar. So when we talk about Arctic polar circle, that is 66 knot 34 north, then Antarctic southern polar circle, that is 66 knot 34 south. Anything north of the Arctic circle or the south of Antarctic circle is therefore to be the circumpolar zone. Okay, so the question here is the Earth's current axial tilt, that is 90 degrees / 23 degree 26 knot. At these parallels, at least one of each summer of the center of the sun stays continuously above the horizon for 24 hours, giving the famous midnight sun. Celestial objects for an observer at an latitude, every star whose declination delta satisfy is circumpolar. Okay, I don't want to get into... Okay, circumpolar is also applied to species like Arctic fox, polar bears, indigenous cultures, and environmental treaties that encircle a pole within those latitudes. So I think that's a particular definition we like to stick, and we can work around it. So let's take circumpolar, the understanding or the application to species or the understanding of objects, carriages, that includes Arctic fox, polar bears, indigenous cultures, and environmental treaties that encircle a pole within those latitudes. Okay, this is good. So probably I'll be talking about the space science in maybe tomorrow, not today. So this is B64G1/105, that is space science. And the Earth observation satellites, whether we talk about LEO and the others, the classification would be B66G1/1021. Communication satellites, B64G1/1007. Launch system, B64G1/002. Non-synchronous stations, we have H04 B7/195. Station keeping, B64G1/2429. Geosynchronous orbits, B64G1/2425. Constellations are part of B64G1/1085. Remote sensing is there. I don't want to get into the angles right now, but if the angle has to be understood, every satellite has about orbit inclination between 70 to 90 degrees, and the others, So when we are talking about sending signals to the described constellation between two satellites and receiving at the base station, we will talk about the understanding in terms of what are the protocols which are being utilized right now. Maybe I'll go through it a little bit deeper and then we'll discuss it in detail. Thank you for watching it out. So I have given you a consensus of the understanding of what can be utilized on the Impula network. Rather than I would focus on giving the right input data set, because that is going to give you some kind of control data, and that control data at one end of the spectrum. At the other end of the spectrum, we have the monitoring modules, which we have been talking about over some weeks now, and just put the quantum stuff or whatever you know in whichever way you know and deploy that and see how it works for you guys. Thank you for watching it out. Thank you for pouring so much love on the DMs. A lot is happening. Let's see how we are able to get it done in a fast, speedy manner, because that's the mandate to achieve the 2030 goals first. So once we are able to achieve the 2030 goals, then we take this to the next level of understanding.